Good afternoon, students. You welcome back to the second lecture on Statistics and Probability 1, EBS 350. The other time we met, we talked about the definitions or some of the terms that are involved in statistics, especially the cause under consideration. We talked a lot about the definition of statistics. We considered the types of statistics, which we said we have the descriptive statistics, we have the inferential statistics. After that, we came to talk about terms like population, sample, we talked about data, we talked about information. They also talked about variables. Remember, we said we have two types of variables. We said they are the qualitative, we also have the quantitative. Under the qualitative, we said they are non-numeric, that is, they don't assume numbers. We also said they are mutually exclusive, that is, a variable or a data value should belong to one and only one category. We also said they are exhaustive. Then we came to talk about the quantitative variables. And we said for the quantitative, we have two types. And we said there, they assume values. They assume numbers. And we said that the two types include the discrete variables. And we said that we have the second one to be the continuous variables. We should also know the difference between the continuous variable and that of the discrete, and examples of them. We mentioned all these things over there. Then we came to talk about the scales of measurement, where we said we have the nominal to be the simplest, followed by the ordinal, to the interval, to the ratio. Now after that, we talked about sources of data. Where do we get our data? We talked about we can get data through the use of questionnaire, through the use of interview, through experiments, and we can also do observation. We can have survey. All these things will give us data. We also talked about the types of data. We talked about the actual sources of data. We said we have two primary sources. We have the two sources. We said we have the primary source. We have the secondary source. But the methods of data collection, we said we have the use of questionnaire. We can talk about observation and others. Today, our topic is going to be on organization of data. After you have gotten your data, how do you handle the data so that one can read meanings out of the data? Well, remember we said for the raw data, they are collected from the raw facts. And so when we have them in raw facts, meanings cannot be read out of it. And so it is when they are turned into information, that is where we can read meanings out of it. So now we are going to look at how we can present data so that one can read meanings out of it. Now we have two main ways of presenting data to make them meaningful. We can present data in two main forms, so we can group data, we can organize data in two main forms. And we said that we are saying that the first one is by the use of what we call the frequency distribution tables. So we can use the frequency distribution tables to organize or transform our data. We can also use graphical representation. So we can use frequency distribution tables, and we can also use the graphical representation. Remember, when you want to draw the graphs, you will need the tables. So we are now going to start with the tables. When we are done with the tables, then we are now going to consider how we can draw graphs out of the tables. For the frequency distribution tables, we can have the ungrouped and then we can also have the grouped. So we can have the ungrouped frequency distribution table, and we can also have the grouped frequency distribution table. I am going to take you through them one by one, and you will know when to use the ungrouped frequency distribution table and when also to use the grouped frequency distribution tables. So let's start with the ungrouped frequency distribution tables. Normally, when you take the data values, you may notice that the gaps in between the data values are so small. They are not all that widespread. And as such, we have to use the ungrouped frequency distribution tables. For instance, if you are teaching in a JSS class and ask the students to give you their ages, you will see that the ages will be so close to each other. And so in that sense, it will be appropriate to use the ungrouped frequency distribution tables. Now let's take a look at this particular data. So like I said, if it is about the ages of students in maybe a particular class, JSS class, you will notice that the data values or the ages that they are going to give you will be so close to each other. They are not widespread. In that sense, there will be the need for us to use the ungrouped frequency distribution table to present the data. So let's take, for instance, the ages of some 20 students in a particular class are 19, 18, 18, 21, 22, 17, 19, I hope you are writing them, 20, 21, 18, 18, 20, 17, 18, 19, 18, 19, 19, 17, 20. Okay, so I'm going to put them on the board for you to see. So we have 19, 18, 17, 18, 21, 22, 19, 18, 20, 21, 18, 18, 20, 17, 18, 19, 18, 19, 19, 17, and then 20. So these are the ages of the 20 students in the class. And if you go through the data values, you will see that the data values are closer to each other. And therefore, we are going to use the ungrouped frequency distribution table. Now, before we do that, I have to tell you that a typical frequency distribution table has 3 columns. A typical frequency distribution table has gotten 3 columns. And these columns are what we call the variable column. We have the tally column. Then we also have the frequency column. Now the variable talks about the type of data that you are talking about. Which variable are you considering? In this particular data, we are talking about ages of students. So in this case, we are not going to put a variable here. We are not going to write this variable as a word here. But we are going to use the variable under consideration. In this sense, the variable under consideration is what? Ages. So we put ages there. The tally is going to guide us to get the frequency. And so we are going to make the strokes. Whenever we cross it here, we come and do that. And then after that, we count the number of strokes to get the frequency. What is it about the frequency? The frequency talks about the number of times a particular trait or an attribute occurs in the data values, or an attribute appears in the data values. So now we are going to do that. In doing so, let's go through our data values and look for the smallest value. Okay, we are going to look for the smallest value. So in doing so, when you go through, you see that the 17 is the smallest value. So write for 17. After 17, the next value to come is what? 18. And then the next one is 19, 20, 21. And I think the highest value in this case is what? 22. 22. So I have ordered the data values according to, or I've done that in the ascending order. That is, I've arranged them from the smallest value to the highest value. It is not obligatory, or we are not saying that always we should begin from the smallest value to the highest. We can also start from the highest and go to the smallest value. But ideally, we always expect that you start from the smallest value and get to the highest value. So now we are going to do the tally. And normally students get confused when they get to the examination hall. They don't follow instructions. The instructions are that we are not going to count the number of 19s there and put it for the tally. But let's go through this. Because we are teachers, we are going to teach our kids. Let's show them the right thing to do. So now we are going to do the strokes here. I will cancel 19 and come to look for where the 19 can be located. You will do so. I will cancel 20. Look for 20. You will do something like this. 19. You will do it for the 19. So I'm going to call some of the students in my class. I have Priscilla with me here. Priscilla will come to the board to come and do same for us. Do for about two of the data values. Then we continue from there. Priscilla, help us. So we are going in this way. You cross 19, 18. So
we have 21.
Okay.
We have 18 again.
18 again.
18.
Okay. 17. Okay.
18 again.
Okay. Thank you. Priscilla, thank you. So let's continue. So Priscilla go to 18. I'm going to continue from there. 19. You come 21. You come 18. Now I've gotten 4 of the 18s. So the 5th one, I'm going to cross it in this way. 19. I'll have this. 22. The last one. 20. I have it here. 17. Like this. 20. 20. Also in this way. Then 19. I have 4 of the 19s, so the 5th one will be used to cross it. And then 17 is also in this way. 18. Like this, then 18 like that. So when we are done, we are now going to count the number of strokes that you have gotten under the telly, and when we do the counting, that is going to represent the respective or the corresponding frequency. So for 17, Priscilla, how many did we get?
3, 1, 2, 3.
So you got 3, so you put the numeral 3 here. Okay. 18.
1,
Yeah.
2, 3, 4, 5, 6, 7.
So you got 7 for the A19. Then 19, you're also getting 5. For 24. 21. Priscilla.
1,
And then 22.
1.
1. Okay. Now when you are done with it, you have to add the frequencies to make sure they actually match with the number of data values here. Okay, we said we had the ages of 20 students in the class. So now let's go through and add the values here and see if you are going to get the 20. If they are not up to 20, then there's a mistake elsewhere. You have to go back and check. Or you count the number of values, the data values, to check whether they are up to the 20 stated in the question. So now we add 3 to 7, that is 10, to 5, 15, to 4, 19, to this, 21. You will notice that the data values or the addition is more than the 20. So let's go through and count our data values to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Even though they stated in the question that we are to use 20 data values, you will notice that they are up to what? 21. On that day, if you are to meet such a challenge, don't change anything. Don't change any of the data values. Work with that. So now we assume that we are dealing with 21 data values. Are you all together? Thank you. So when we have the data, the table in this form, this table is called the ungrouped frequency distribution table. Thank you. Okay, so I'll give you an example. I'll give you an example for you to try on your own. Get an ungrouped frequency table for me. If we can copy, the data values are 0, 10, 8, 0, 0, 8, 6, 5, 1, 6, 1, 4, 10, 8, 7, 0, 10, 9, 4, 10, 10, 7, 6, 10, 9, 1, 5, 1. Okay. So let's count the number of data values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So which means that the data values are up to 28. And you will notice that this talks about the marks obtained by students in a class. The exams the exercise was conducted, it was marked over 10, and these are the scores obtained by 28 students in the class. And so they want you to use this particular data to draw an ungrouped frequency distribution table. This is an assignment for you. I want you to try your hands Okay. Now that we are done with the ungrouped frequency data, remember I told you we have two ways of doing that. And the second way is by using what we call the grouped frequency distribution table. So for that one, normally we use that one for data values which are widespread. So let's assume you have conducted examination and you have marked it over 100. You will notice that most of the students will score some marks like between 10 to 0 to 10. Some will score between 10 to 20 and so forth. Let's assume some are scoring 5, some are scoring 99, others are scoring 55, others are scoring 40 and so forth. The data values are widespread. So in order to capture all the data values, we are going to use intervals. We are going to use intervals and capture them in the form of intervals. Okay. Now intervals here, we can have what we call the equal class intervals. And then the next one we can have unequal we can also have the unequal class intervals. Okay. Now, if for the sake of examination, normally when they give you the question, they will give you using a particular set of intervals. And depending on the interval, we can also get the group frequency distributions. But here, if you want to get the class intervals, there are some things we have to take note of. The first one is that we are saying that the intervals should be mutually exclusive. The intervals should be mutually exclusive. What it means is that an interval should be able to take one and only one particular data value. That is, a particular data value cannot belong to two intervals. So if a particular data value belongs to one interval, it should be there. It cannot belong to two data class intervals. That's why we say that it should be mutually exclusive. We are also saying that the data values must be exhaustive. They must be exhaustive. What it means is that the data values must be able to contain all the data values, must be able to absorb all the data values. So what it means is that by the end of your construction of the data interval, the intervals, there shouldn't be a data value that will not get an interval to fall within. So that's why we are saying that they should be exhaustive. They should be able to exhaust. They should be able to take all the data values. Okay. Then the next one is that it should be continuous. It should be what? Continuous. What it means is that when you are constructing the class intervals and there's a data value that falls in the middle part or any part within the intervals that you have constructed, and there's no data value that will fall within that particular interval, you should still put it there, and then when you go to the frequency, it's going to be scored as 0. Okay, so we are saying that they should be mutually exclusive, they should be exhaustive, and they should be continuous. As we move on, you understand the terms mutually exclusive, exhaustive, and that of continuity or continuous. Okay. So now I've said about the fact that we can have the unequal, we can have the equal class intervals. When do we say the class intervals are equal? It means that when you check the class sizes or the class intervals of all the, when you check the class width or the class size of all the class intervals, they should give you the same answer. They should give you the same answer. So if all the class intervals are equal throughout, then we say they are equal class intervals. But when we have even one, at least one of the class intervals, which is not giving you the exact class sizes of the rest, then it means that we have unequal class intervals. As we move on, you're also going to understand most of these things as well. Now let's take a look at this particular data. And then when we have the data, we are going to use the data to construct a group frequency distribution table. Now the figures below are the length of iron rods measured in centimeters to the nearest centimeter. And then the values are 60, 70, 45, 68, 72, 67, 57, 70, 48, 42, 64, 65, 68, 54, 72. Let's assume that we are looking for the figures that were obtained when we have measured the length of iron rods in centimeters and to the nearest centimeter. And these are the measurements that we got. We got 60, 70, 45, 68, 72, 67, 55, 48, 42, 64, 65, 68, 54, 52, 68, 58, 74, 75, 50, 50, and then 60. You will notice that when you go to the data values, they are widespread. They are not as close as the one we just did. They are close to, they are widespread. Okay? And so in order to capture them, there is the need for us to go for what we call the class intervals. And in most cases, they will give you the class intervals as to where to start, if it is for the sake of examination. Okay? If it's not for the sake of examination, then for the fact that it should be exhaustive, you should make sure that you look for the smallest data value there, you look for the highest data value. And that is going to guide you to determine when to start and when to end. Okay. But here they are saying that using a class interval of 40 to 44, 40 to 44, 45 to 50, and so forth. Okay? 40 to 40, 45 to 49, sorry, 45 to 49, and then 50 to 54, and so forth. Construct a frequency distribution table for the data. Construct a frequency distribution table for the data. And so how are we going to do that? So what you need to do is that you are going to get the 3 columns that I told you. The first column talks about the variable column. The next column talks about the Telly column. And then the last one talks about the frequency. Now, remember, for the variable here, we are talking about the figures of length of some iron rods that were taken or that were measured. Okay, so we are now going to take this variable. What do you think will be the variable? The variable is going to be length of iron rods. Okay, maybe in centimeters. So the length in centimeters. The length in centimeters is going to be the class interval of the variable there. So you have the length in centimeters. And so they have given you the class intervals to use. So the first class interval is 40 to 44, 45 to 49, 50 to 54, 55 to 59, 60 to 64, then 65 to 69. Okay. You can continue, you have to continue because the last or the highest value, if you go through, is 75. The highest value there is 75. It means that we have to continue, okay, till we get to 75. Okay. So now, what it means is that maybe I have to work this for you to see, and then work the data value so that we can get all the class intervals there. So I'll have the length in centimeters. We have the tally. And so we also have the frequency. So they are saying that the class interval should begin from 40 to 44, then 45 to 49, 50 to 54, and then 55 to 59, 60 to 64, 65 to 69, 70 to 74, and then 75 to 79. And I think if you go to the data values, the last data value is going to fall within this particular interval. Okay, so we are now going to do the telling. So now what you do is that you go to the data values and then you start doing your slope. The data values that I gave you, you will notice that 60 is the first data value. So you cross it here. The next one is 70. 70 is within this. So now we have gotten the three columns. The variable column talks about the length in this question. We talk about the length of some measurements. And then we are talking about the tally and how the frequency. So we are going to do the tallies to get the actual frequencies. So the first number is 60, and 60 can be captured within this particular interval. The second number is 70. 70 can be captured within this interval. 45 is here. 68, you can find it here. 72 can be found here. 67 can also be determined here. 55 is found in this particular range. 48 is also found within this particular class interval. 42 is found here. 64 can be determined here. 65, we can find the 65 here. 68 can be found in this region. 54, you can find it here. 52 can be determined here. 68 is located here. You will notice that we have 4 slopes already, so this one should be used to cross it. And then 55, we have 55 also there. 74 is also found here. 75 can also be determined or can also be found within this region. Then 50 is here. And of course the last one is 60. You can find 60 here. So when we are done with that, let's then count the tallies there. And then when we count the tally, that will give you the corresponding frequencies. So the first frequency we have just a slope, so it means 1. The second we have 1, 2, 2, 1, 2, 3, 3, 1, 2, 2, 1, 2, 3 is 3, 1, 2, 3, 4, 5, 1, 2, 3, then 1. Once again, when we are done, let's add the frequencies and make sure they actually match with the number of data values given. So we are going to do that. This plus this is 3, 6, 8, 11, 16, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it's actually confirmed that. Now let's look at something. I was talking about the fact that the data values should be mutually exclusive. This is the table, the group frequency table, drawn for the data above. Now you notice that when we talk about the fact that the data values or the class interval should be mutually exclusive. You will notice that from 40 to 44, we just came to 45 to 49, which means that if there's a data value which is going to be located between 40 and 44, that data value can only be here, can only be within that class interval and cannot be here. But if it were to be 44 starting from here, and if there's a data value say 44, where do we put it? Are we going to put it here or we are going to put it there? It is not going to be possible. And so once we have it to be 45 in this way, then this data value 44 will have a place to be. And that's why we are saying that it should be mutually exclusive. We are also saying that it should be exhaustive. The class intervals should be exhaustive. We've seen that by the end of the day, the class intervals have been able to take care of all the data values. So all the data values here have been able to be placed within the class intervals here. And so all of them have gotten places to be. And that's why we are saying that they are all exhaustive. Then we are saying that they should be continuum. There should be continuity in it. So the data values, the class intervals must be continuous. And then we are saying that because you will notice that if there is a data value which is here, but cannot get even a place here, something like if we were to start from 35 to 39, you will notice that none of the data values here will fall between 35 to 39. And that's the more reason why we do not include 35 to 39 here. And you also notice that there's no data value which is going to fall between 80 to 84. And that is why we did not include them. So at the initial stage, when the data values are not going to be captured or cannot get an interval to be, we don't include it. And at the finishing end, when it is ending, you don't have to also end it. You don't have to also include it there. But when it is within, we have to include it. That is the continuity that I was talking about. Okay. Thank you. We are going to do some short exercises here. And when we are done with that, we are going to stop for the day. Now the first one that we are going to know is what we call the class limits. The class limits. When we talk about the class limit, they are found from the class intervals. The class intervals have gotten the starting point, it has gotten an ending point. So where it starts is the lower class limit, and this one is the upper class limit. So lower class limit, upper class limit, lower class limit, upper class limit, lower class limit, upper class limit, and so forth. So we have what we call the class limits. Okay? We can also talk about the class made points. Class made points. They are the class made points or the class max. The class made point or the class max. And how do we calculate the class made point or the class max? We say it is the average of the class limits. The average of the class limits. Which means that I will take the upper class limits and add to the lower class limit and divide by 2. And that gives me the class made point. So for this class, the class made point is going to be 40 plus 44 divided by 2. And this is 84 divided by 2. And this is going to give you 42. So the class made point here is 42. That's the midpoint of the class, the middle part of the class. So the class made point is calculated by adding the class limits and dividing by 2. In other words, we say the average of the class limits. The average of the class limits. The next one under consideration is what we call the class size. But before I calculate the class size, let me also talk about what we call the class boundaries. The class boundaries. When we talk about the class boundaries, it is the highest or the minimum within which a class interval can be, or within which a data value can operate within a class interval. Okay? So you will notice that this class is beginning from this end, ending at this point. Now before the 40, there was a number. So let's assume there's another class interval starting from somewhere coming to the 40. Then that class interval is going to end at 39. So let's assume it is coming from this place. Then you will notice that this class is also ending, for the class here is ending at 44. So between this class and this class, from here to here, there is a gap left in between the 40 and that of the 45. And between the class starting from somewhere ending at 39 and that of this class beginning from 40, there's also a gap over there. And so if you want to get the class boundary, that is the maximum or the minimum within which that class can operate, then what it means is that this class can be extended to a certain point, but that is where it is going to end. Where it is going to end is going to be the beginning of this class. So let's assume we are talking about the boundary between Ghana and maybe Togo. There is a line there, okay? And that is the end of Ghana. Where you get to that line, you are ending Ghana. You are ending at Ghana. And that will be the beginning of Cote d'Ivoire. So where it ends is the beginning of somebody's. So what you are going to say is that between this 44 and 45, there is a difference of 1. And that is the difference 1. And so to get that point where this class can end, we are going to divide this one by 2. And that one is going to give you 0.5. And so that 0.5 is going to be added to this one. And when we come here to, when we want to go back, we are going to get to 39. That is going to be the upper class limit of the class that comes before the 40 to 44. And so that one too is going to end at what? 39.5. Because there's going to be between 40 and then 39. And so we find the difference between the 40 and the 39, that also gives you 1. And we divide that one by 2, and that also gives you 0.5. So it means that our class boundaries are going to be something like this. Let me get the class boundaries for you. Are going to be where this one ends is what? 39. And so between 39 and then 40, there's a difference of 1. We divide that one by 2, and that is 0.5. So that 0.5 is going to be the maximum of that class, which is approaching the 40, and that is going to be 39.5. And this one is going to be the maximum. If you add 0.5 to this one too, it's going to be 44.5. And that one is going to be the maximum of this particular class too. So that one is going to be 44.5. Which means that this class is now going to have the maximum it can operate and the minimum it can operate. That is the 39.5 to the 44.5. And you will notice that where this class is ending is the beginning of the next class. Like I told you, where the boundary between Ghana and Togo, where the line of Ghana ends is the beginning of that way, Togo, or that of Togo. So where this class is ending is going to be the beginning of this class. So that one is going to be 44.5. And then this one, the highest point is going to be 49.5. And where this one is ending is the beginning of the next class. It's going to be 49.5. And then this one also ends at 54.5. And then it comes back 54.5 to 59.5. Then 59.5 to 69.5 to 60. To 60, 59.5 to 54 to 64.5, and then 64.5 to 69.5. Then we go back 69.5 to 74, and then where this one is ending is the beginning of this one. So 74.5 to this one is also ending at 79. So these are what we call the class boundaries. I think you have noticed how the class boundaries are going to be calculated. And this is the way it should be done. This is about the class boundaries. The next item that I'm going to add is what we call the relative frequencies. The relative frequencies. Okay? Okay. So that one, when we know the frequencies, we should be able to calculate that one. And so when the frequencies were, we have the frequencies to be 1, 2, 3, 2, 3, 5, 3, 1. So in calculating the relative frequencies, we are saying it is the frequency of the class divided by the total frequency. The frequency of the class divided by the total frequency. So what's the total frequency here? 3, 6, 8, 11, 16, 19, 20. The total frequency is equal to what? 20. So if I want the relative frequency of this class, it is going to be 1 over 20. The relative frequency of this class is 2 over 20. That of this is 3 over 20. 2 over 20. This one is 3 over 20. Then 5 over 20. 3 over 20. 1 over 20. So we are saying that the relative frequency of a class is the frequency of the class divided by the total frequency. And that gives you the relative frequency. Now we had the class boundaries. And so if we had the class boundaries, we can also use the class boundaries to calculate what we call the class size. We can use the class boundaries to calculate the class size. So let me quickly write down the class boundaries. And then use the class boundaries to calculate the class size. Okay? So we said we have 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5, 54.5 to 59.5, then 59.5 to 64.5, 64.5 to 69.5, 69.5 to 74.5. The last one is 74.5 to 79. And so these are the class boundaries. Class boundaries, you can call the class, you can get the class size, or what we call the class width. And it is simply, when we come to the class boundaries, we have the lower class boundary, upper class boundary, lower class boundary, upper class boundary, lower, upper. So it is simply the fact that we are going to subtract the lower class boundary from the upper class boundary to get the class size. Lower class boundary from the upper class boundary, lower class boundary from the upper. So to get the class size of the first class, it's going to be 44.5 minus 39.5. And that's going to give you what? You do that, it's going to give you 5. You do for the next one, 49.5 minus 44.5. So when we subtract the lower class boundary from the upper class boundary, we get the class size. But we can also do that one by what we call counting. We can count with the class limits inclusive. So the first one is 40, 41, 42, 43, 44. That's the first one. So 40, 41, 42, 43, 44, 5. 45, 46, 47, 48, 49, 5. So we can do that by counting, by adding the class limits to that. And so we are going to end our lesson here. And I hope you are not going to forget. All what we've said today is about data organization. We said we can organize data by putting them into two forms. It can be in the form of a table, it can be in the form of graphical approach. And we said that for the table, we can have the frequency distribution tables. We can have the grouped, we can have the ungrouped. And I've taken you through that. I want you to practice your hands on them. When we meet again, we are now going to look at when we have the table, how do we then use the tables to draw our graph, the various graphs that we are going to draw. Thanks for coming. God bless you.